Okay, I'm gonna look on P, just looking at number one. So let's talk about a few things that come with this. We have a lot of information um, that we can work with, but on number one, they tell us we have h at t, negative 16t squared plus 72t plus 36. Okay, of course you can change the t's to x's if you want. This is the height equation. Basically, a few things that know. This is just kind of a constant that takes place. This would be initial velocity. So if it was positive, that was up. If it was negative, it would be down. If it was zero, that means it just falls off something. Okay, like my initial velocity here, if I rolled my pencil off this desk and I didn't throw it downward, it just rolled off the desk, you have an initial velocity. If I take this pencil and I throw it upward, I have an initial velocity that's positive. If I throw it downward, I have an initial velocity that's negative. And then this is the starting height. It's like we're on top of a platform that's 36 feet in the air. Okay? But this says a t-shirt is fired from a launcher with initial upward velocity of 72 feet. So upward means that 72 on the linear component has to be positive. From a height of 36 feet. So if someone's on like a ladder or a stand that's 36 feet above the actual ground. Okay, so we can do all of the things to this problem that we've already known how to do. But we can also use the calculator to help us on it. Okay, so I'm going to, on the calculator, So I'm just going to go y equals, I'm going to clear this out. And if your plot is ever on, we will eventually use the stat plot, but if it's on, it'll be darkened like that. I don't want it on, so just go up to it and bring it down to where it just says plot 1, plot 2, plot 3. That has to do when we're going to plug in data. Okay, so if I'm going to graph this equation now, I'm not going to use t, I'm going to use x, because the calculator uses y and x. So I have negative 16 x squared plus 72x plus 36. Now, if I hit just graph as is, it's whatever my last graph was. So my last graph had a window that was outside of this. So if you can't see your graph, that doesn't mean your calculator's broken. It just means it's in the wrong location. Okay, so the nice thing is your zoom button will do quite a bit of things for you. So I always say, you know what? If you go back to zoom standard, which is zoom 6, that takes it at negative 10 to positive 10 in both the x direction. I clearly can't see all of this, so some people like the zoom out feature. I like the zoom fit feature. The zoom fit feature tries to have all of the important features of the graph, like the max or the min, the x-axis crossing, the y-axis crossing, and then stuff like that. So if you go to zoom fit, which is going to be 0, zoom 0, this shows quite a bit of things about our graph. Now, the stuff way down here is not really that relevant, but I can see that it does cross the x-axis here and here, crosses the y-axis here, and I can show that I have a maximum value. Okay? So if I answer these questions by using the calculator, it says, find the maximum height of the t-shirt. Okay, so what I'm going to do is I want to find this max. So I'm finding the vertex. So I could use the negative b over 2a, plug it back into the equation, and get the y component out. Okay? But I'm going to do this. I'm going to go to second and then trace, which is the calculate button. I want to find a maximum value because my parabola is opening downward. That means the vertex is a max. Okay, so I'm going to go to number 4. My cursor is on the left side of it. I'm going to hit enter, and I'm going to move it over. My cursor, it's coming over to the other side. It's definitely on the downward. I'm going to hit enter one more time. I don't know why the guess feature is in there. I'm not a fan of it. So I hit enter one more time. So this says that at 2.25 seconds after I've launched this t-shirt, my t-shirt will have an elevation of 117 feet above the ground. Okay? So at 2.25 seconds, so it was launched. As soon as it left the launcher, it's heading upward. It started 35 feet above. So let me write this down to the side so I can go back to my other board. So what's taking place on this, as I was I was on this platform that was 35 feet above the ground. I launched this, it came up, and then it came back down. Okay? Yes, this parabola exists over here as well, but this is not important information because we are on top of a platform. So the vertex is at 2.25, 117, which means at 2.25 seconds, so starting here at 0, it launches 2.25 seconds into flight. It's at 117 feet in the air, above the ground, not above our platform. Okay? And then find the time it takes to hit the ground. So let me ask you this. Is the distance to here versus the distance to here, which distance just visually appears that it was in the air longer? Was it in the air longer to get up to its maximum height, or was it in the air longer to get all the way back down to the ground? Yeah, get back down to the ground. Okay? Why are we not including this portion? This portion here is because I'm up on a platform. So if we didn't have the platform, we would be able to see the whole parabola. So this yellow version, it's only 2.25 seconds up into the air. So it's going to take a little bit more than 2.25 seconds to get all the way down. Now, if we were at the ground level and we shot it up, the time on the vertex is half the time that it would take to come all the way back down to the ground. But being that I was already elevated when I launched, it's going to be a little bit different. So the next thing I want to find is I want to find where it crosses the x-axis. I'm not worried about where it crosses the x-axis over here because that's negative time. Okay? I'm worried about where it crosses the x-axis right here. So I'm going to go back into the calculator. I'm not worried about this. I'm going to actually change my window a little bit. Let's go negative 5 there. And I'm not too worried about this. I'm going to go like negative 10 in the y minimum to, that works, graph. So what I did there is I've changed my window so it looks a little better. I'm not worried about where it's crossing right here because that's a negative time. This height right here is where it started, my initial starting point. This is where at 2.25 seconds I was 117 feet off the entire ground. Now I want to find where it crosses the x-axis. Where it crosses the x-axis is called a 0. Okay? So I'm going to go second, back to trace. I want to figure out a 0. A 0 is where it crosses the x-axis. So you go to number 2, and you bring your cursor. The most important thing with the cursor on this is I need to go above and below, or below and above. Okay? There has to be a sign change. Okay? Right now it's at 32.7, roughly, in the y direction. That's a positive number. I'm going to hit enter, and I'm going to continue to bring this down. And once my y value becomes negative, that means there's a sign change. If there's a sign change, that means it has to have crossed the x-axis in between those two regions. So I'm at 5, negative 14, which you can't really see on here. I'm going to hit enter. Do I want to guess? No. So it looks like at 4.95 seconds. So a little bit more than 4.95 seconds. I mean, we're just rounded. It's 2 decimals. At 4.95 seconds, right after we launch it, that t-shirt will be in the air for 4.95 seconds before it hits the ground. Okay? How do I know it's at the ground? Because my y value is 0. Okay, these are things that you could do by using the completing the square, by using the quadratic formula, by doing factoring, by using negative b over 2a, plug it back in. Those are all things you can do. But the calculator becomes a very valuable tool for you in this. And I can assure you, there's nothing you can do other than submerge your calculator underwater or drop it off a high building. You know what? You're not going to push buttons that are going to make it break. Okay? If you ever get into a situation where your calculator, it seems like you're like in the impossible death spiral. If you don't have anything on your calculators, if you didn't put any programs on it or anything like that, if it's just the plain Jane calculator, you've added nothing to it, you can always do this. You can go second. Where's the reset button? I can't see, it's too blurry. So I have a calculator I can look at. I just need to look at your screen. Second memory, maybe. Yeah, second memory. I can reset my calculator, so hit 7, all RAM. If you have anything in there, don't do this. Like, meaning if you have programs you've already pre-programmed, don't do this. It'll get rid of them unless you archived them. But if you go into the second reset, what that does is it clears out any lists. It clears out any graphs. If you made your graph goofy somehow, this kind of just, it starts it over. Okay, if you have programs on here, don't do it unless you know how to archive it. And if you have questions about it, please have me take a look at it, because I'd hate for you, because I know some of you have the quadratic formula program in there, some of you have the midpoint formula, some of you have the distance formula. These are all formulas you could program into the calculators. If you know anything about programming, it's a really easy programming to use on these, but it's kind of fun. So does that help you out a little bit? Was that kind of like what I was saying on the video? I forget it. It's been like 3 weeks since I've done the video. Okay. Is there anything else, NOP, you would like to take a look at, my friends? Yeah.
Number 29 on N.
29 on the letter M as in Mary? N?
Yeah.
N. Nancy. Who's Nancy? I don't know. And I'll just keep recording. I'll just put this up in case anyone wants to watch it. $29, letter N. Oh, great one. Okay. Write the quadratic equation that has these solutions. So basically what this was done on this problem is these are the answers we would have gotten if we either completed the square or we used the quadratic formula. But now we want to work backwards to solve it. Here comes a sneeze. That's it. Don't go down there. I sneezed down there. All right. What I'm going to do on this problem, I'm going to go x equals on both of these. Is that okay so far? And what I want to do is I want to just start solving it. So I'm going to multiply both sides by 4 here. Is that okay? And then I want to bring everything over to the left side. So let me just stop there, and I'm going to put it in parentheses. Okay, all I did is I wanted to make it equal to 0. So by moving everything over, moving this over and moving this over, I wind up with that. Okay? I'm going to do the same thing to this one. So I'm going to make this 4x equals negative 5 minus I root 15. I'm going to move everything over and put it right next to it. Does that seem okay so far? Make sense? Okay. We are going to do a triple distribution. It's foiling on steroids. Okay? So what I'm going to do is this. Let's change up colors. Let's go orange. So this 4x I'm going to multiply times all three of those, first thing. So 4x times 4x is 16x squared. 4x times 5 is plus 20x. 4x times I root 15 is plus 4ix root 15. Seem okay so far? I just distributed. That's all I did. Now I have to do the same thing with the 5 as well. So let's change colors. So I'm going to distribute the 5 to each of these. 5 times 4x is 20x. 5 times 5 is 25. 5 times 5I root 15 is 5I root 15. And then the last thing, I'm going to distribute the negative I root 15 to here, to here, and to here. So I root 15 times 4 is going to give me negative 4ix root 15. This negative I root 15 times 5 is negative 5I root 15. Negative I times negative I is negative I squared. So I'm going to go negative I squared times root 15. Root 15 times root 15 is root 225. 225. Oh, shoot. Come on. Clear this up, Chris. Root 225. Okay. Now, I have this up there for two reasons. One, I ran out of room. But two, what is I squared equal to? Negative 1. So this becomes negative negative 1. What's root 225? 15. Negative negative, positive. 1 times 15, 15. Okay? So that metropolis of the multiple, triple over ugliness, I'm going to start combining like terms. Do I have any other x squareds in there? I don't believe so. Okay? I have a 20x, and I have no other like terms like that. So that gives me plus 40x. You feel comfortable with my math so far? What can you tell me about this and this? They cancel. Why do they cancel? They're exact opposites of each other. One's positive, one's negative. So this cancels this. Okay? Plus 25. I have no other things in there. Oh, I have plus 25 and then plus 15. Plus 25 plus 15 is plus 40. What can you tell me about this and this? They also cancel. So 16x squared plus 40x plus 40, if I complete the square on it or I use the quadratic formula, would yield me those answers. Now, a little trick. Anytime you have one answer that has an I in it, it also has its conjugate pair. Imaginary numbers always come in pairs. There's always a positive and a negative component. Okay? So if I said, hey, one of the solutions is 3i, that means the other solution has to be negative 3i. They always come in pairs. And that's something that when we start getting into polynomials that we'll deal with a little bit more. What else did you see on the homework that you would like to have a little more? Does that help you on that one? That's an ugly problem. I'm sorry. I will give you one similar to it. Might not be quite as meaty. It might be like 3 plus 2i and 3 minus 2i. You go through the exact same process. Okay? And if that's the exact problem that I just said, I didn't mean to. I got lucky. Or you guys got lucky. Anything else? Yes?
Can we do number 7 on P, please?
7p. You got it. Is this the one if a toy rocket is launched? Is that the one? Okay. All right. If a toy rocket is launched from the ground level, so it's launched from the ground level with an initial velocity of, so we're going to call that, this is going to stand for initial velocity, which is 128 feet per second. Okay. When will it be 112 feet off the ground? Okay. How high does the rocket reach? Okay. So first thing I'm going to do is I'm going to use h at t equals negative 16t squared plus v naught t plus h. Okay, so the negative 16 basically stays as a constant. The v naught means this is our initial velocity, this is our initial height. Okay, so this is, our rocket's going to do something like this. That's what it's going to do. Okay, it's going to be a level ground, it's not going to be sloped because, you know, most things. So what I'm going to do is I'm going to plug in things that I know. I'm going to plug this in. So I know that h at t equals negative 16t squared plus 128t. The reason it's positive 128 is it was an upward initial velocity. If it was thrown downward, if you're on top of the building, you threw it downward, it would be negative. Okay? Okay, be careful here. We launched from the ground. So what is my initial height? 0. This should actually be h naught. So h naught is equal to 0 because we were at the ground. Okay? So we can use the calculator on this one. We could try and just work it out by hand. So I know that basically my parabola is going to do this. So I have a 0, 0 here. I'm going to have some sort of vertex here. And I'm going to have another something comma 0 here. Okay? The something comma 0 is when does it hit the ground. The vertex will tell us when it is at its maximum height. So I'm going to write this over here. So I have negative 16t squared plus 128t. I'm going to go refer back to the calculator. Okay, so I'm going to go y equals, I have negative 16 x squared. Make sure when you're doing the negative, it's the negative in parentheses, not the subtraction key, plus 128t, or 128x. Okay, if I graph mine right now, I kind of see some of it. What did I have to do to find more of it? Zoom fit. So zoom fit, which is zoom 0. And that shows a good amount of it. I might want to change my window because I don't really care about the stuff that's way down low. So you go into window. I think the X min, maybe we can change to like -2. X max looked fine. I'm going to change that to like -10. So it's only going to, but 255 seems good. So if I do that, that's a really nice clean look at my parabola. So I changed the window. Can I see where it crosses the x-axis? Yes. Okay, can I see the vertex? Yes. Now here's the question. This said, if a toy rocket is launched from the ground with an initial velocity of 128 feet per second, when will it be 112 feet in the air? Okay, when will it be 112 feet in the air? So I'm actually going to do this and graph this. So I have a horizontal line. So I know it went higher than 112 feet because at this x value here, that's a certain time, and at this x value here, that's a certain time. That's going to tell us when our rocket was 112 feet off the ground. So the blue and the red graph are two graphs. If I find the intersect of the two graphs, that'll tell me the time that it happened to be 112 feet off the ground. So I'm going to go to second, calculate. I want to find an intersect. So with this intersect, what you want to do is you want to take your cursor, and it's only going to give you one intersect at a time. So I'm going to say I want that intersect. I'm pretty close to this value right here. So I'm going to hit enter. First curve, second curve. I'm going to hit enter as well. Guess. I don't want to guess. Enter. So at 1 second after this thing launched, it was 112 feet off the ground. So at 1 second, 1 second after launch, it was 112. Now I want to find the other intersect because it came back down through 112 feet. So I'm going to go back in. I'm going to go second, calculate. I'm going to find another intersection. I'm going to move my cursor to really close to that intersection on the other side. Oops, let's get closer to it. So we're pretty close to that intersection. So I'm going to hit enter, first curve, second curve, enter that as well. Guess, no. But at 7 seconds, my parabola, so at 1 second and at 7 seconds, my rocket was 112 feet off the ground. It was 112 on its way up, and it got to 112 on its way down. I can guarantee this rocket went higher than 112 feet because my vertex is above that. So now I want to find my vertex. It was a parabola up and down. Is my vertex a maximum or a minimum? Maximum. So I'm going to go to number 4, maximum. I'm going to move my cursor again. And I'm going to get on the left side of it, where I think my vertex is. So I'm definitely on the left side of my vertex. Hit enter. Move it over to the right side of your vertex. Looks like I'm on the right side of it now. Hit enter. Guess. No, I don't want to guess. So at roughly 4 seconds, and I would say round that, I mean, you have 6 zeros in there before for the next number. So I'd say at 4 seconds, our rocket was at 256 feet off the ground. Say on number 7, a toy rocket is launched from the ground, initial velocity 128. When will it be 112 feet off the ground? At both 1 second and at 7 seconds, it will be 112 feet. How high does the rocket go? It goes 256 feet up in the air. Yeah.
What I did was I factored it.
Perfect.
And I got the same thing with that also.
Perfect. Totally works. Yeah, I just wanted to show you on the calculator. Of course, all of the stuff that we have done in class would totally work on that problem. So if you'd factored it, you'd have this. You can factor out a negative 16t. That gives you t minus 16 goes into 128. I don't know how many times. 16, 32, 4, 5. Is it 5? How many times 16 go into 128? 16, 32, 48, 64. I can't do it in my head. How many times does 16 go in 128? 128 divided by 16, somebody. 7? Okay. Cool. So if I set each of these equal to 0, I get negative 16t equals 0.
Oh, sorry, it's 8, not 7.
It's 8?
Yeah.
That's an 8, okay. So it's 0 and 8. Oh, I didn't find where it came back down to the ground, did I? Yeah, so at 8 seconds it's back at the ground, 0 seconds it was at the ground. If I found the vertex, negative b over 2a, oops, negative b over 2a. So that's going to give me negative 128 over negative 32, which that gives me 4. If I plug 4 back into this, I get negative 16 times 16 plus 128 times 16. And if I did this right, it would be at 256. And then if you wanted to find when it was 112 off the ground, you'd have it 112 equals negative 16t squared plus 128t. Subtract the 112. factor that or use the quadratic formula on it, and it's going to give you the 4 comma 256, or it's going to give you the 1 comma 112 and the 7 comma 112. That's what this will find you is 1 and 7 are the two things that work. Plug 1 and 7 back in to the original. If I plug 1 and 7 back into this, you'd find that this is going to be the 112. So it will definitely work. I just wanted to make sure I showed you on the calculator as well, because it is a pretty good tool for you. Okay, we feel good? Hey, if there's ever a day that we're on remote, that you're on remote, like I guess you're Friday, but normally your Thursdays, Fridays. If you ever get stuck on one of those days and want to do like a Zoom call with me, just send me a text. I'm off like 7th and 8th period, so like at the end of the day, I don't know, it's after 7th period, so like from 1:49 on, I could do a Zoom call with you to go over any of the problems. I mean, as well as on the Mondays as well. The Mondays I'm on the on that iTeams, so I don't know if I showed you this or not. I probably should have, because I'd be a much better person if I did. Groups, no, courses. Go here. Homework collections. Monday office hours. If you click on this, it kind of tells you, so you're looking for Stirrups Monday office hours. And I keep them open the whole time. I'm on from like 9 to 11:30. I just have it on. If you get on and I'm not saying anything or I'm not looking at you, it's because I'm doing something on the other computer. Just say something. I'm happy to meet you on that. But we can also, jump on this type of thing during the week if you wanted to, just send me a text, saying, hey, it's Jennifer from Algebra 2. Can we do a Zoom at this time? Or I'll actually do a Teams at that time. Cool? Perfect? Happy? Get out of here, friends. Have a great day. Take care of one another. We will have a test a week from today, so the Tuesday we'll have some more review.